Bismillah, alhamdulillah, wassalatu wassalamu ala rasulillah. Today, inshallah, we will continue section 3.4 and practice by solving the recitation exercises. The remaining, in fact, I think we have solved like 2 or 3 exercises yesterday. So if you remember, this section is about 2 main ideas, the rational zeros theorem and the Descartes rule of signs. Who can summarize them for me? What is the rational zeros theorem says? It is a tool that helps you to find the rational zeros of a polynomial. So first of all, if you have a polynomial with integer coefficients, the leading coefficient is not 0, the constant coefficient is not 0. You can apply this theorem. How to apply it? It says that the any rational zero for a polynomial, if it has, it will be a ratio between the factors of the constant coefficient and the leading coefficient. To minimize or to reduce the effort and the time of calculating the possible rational zeros, you can use the Descartes rule of signs. The Descartes rule of signs says what? If you have a polynomial with real coefficients, not necessarily integer, the Descartes rule of sign, it is about real numbers. But the rational zeros theorem, it is only about the rational real zeros. So the Descartes rule of sign says that the number of the positive real, whether they are rational or irrational, the number of the positive real zeros is equal to the number of variation in sign of the polynomial, or less than that by even number. For example, if the number of the variation is, let's say, 6, then the number of the positive real zeros will be what? 6 or 2 or 4 or 2, 6 or 4 or 2 or 0. So you have always, and we are talking about a number, so it will be 0. You stop there. We are talking about the number, how many. For the negative real zeros, you will count the number of variations in P of negative x. You will replace x by negative x, and then you will see how many times the sign has been changed from positive to negative, or from negative to positive, or less than that by even number. This similarly. I think actions are stronger than words. So let's try to do actions and apply these 2 ideas to find all the rational zeros of this polynomial and write it in factored form. Please, in your notebook, write down the full solution. I will pass and check everyone's solution. You have a polynomial of degree 3, so it is so easy to factor it and to find the zeros. Just you need to find what? 1 0. If you can find 1 0 for this polynomial, the remaining factor will be of quadratic type. You can find it or factor it if it is not prime polynomial. Right, let me pause the recording. What we need to do first, find. The question is about find the rational. No, you mean the possible, the nominated rational numbers to be zeros for this polynomial. Let's see Abdurrahman what he is doing. You didn't find anyone yet? You did? Who did find the first one?
Found 2.
You are checking the possibilities. No need to do that. Or this is from the class of yesterday. Okay.
Find 2 possible.
You find 2? Is 2? Do you agree with him? 2. 3?
I found 2 here, and I applied opposite of 3.
And it works?
Yes, the remainder is. I think.
So did you try 1 and -1, Shabab?
One.
Clearly 1 is not a 0. If you just use the substitution, I think for 1 and -1, you can use the substitution. But the problem is that you will do it twice. If it is a 0, what you will do after that? You will go and apply the synthetic division. So I advise you to try the synthetic division, especially for the roots other than 0. So first of all, for those who didn't start yet, please find the possible rational zeros.
I found all the
Good, excellent. So how many rational zeros you obtained?
3.
What they are?
+2 twice and 3.
So it is 2. They are 2, not 3.
Yeah, one of them are
The rational, one of them is of multiplicity 2. So I think you are right. Let's check. Yes, the rational zeros are 2 and 3. And which one of them is repeated? 2 is of multiplicity 2. The factored form is like this. So let's solve it. Let's see now what we are supposed to do to solve this one. First of all, you will find the possible, let's write it shortly like this, possible rational zeros. I think it is clear what I mean by that. Possible rational zeros, just abbreviation for that. So what they are? The leading coefficient is 1, so easy. So it will be just the what? The positive, the factors of 12, positive or -2, positive or -3, positive or -4, positive or -6, positive or -12. Why did you thought about? Did you use the Descartes rule of sign?
Yes.
How you use it? Of course, for the positive, how many times the sign has been changed? 1, 2, 3. So this means that there are 3 or 1 positive. This will not help us a lot. But look what will happen if you replace x by -x. Look at p of -x. What will be p of -x? -x to the power 3, -x squared, minus 16x, minus what? 12. How many times, what is the variation of sign here? 0. So this means no what? No negative zeros. This is helpful now. So this means that we will not think about, we will not try any negative number. So the possible rational zeros here are only positive. Look how we use the Descartes rule of signs together with the rational zeros theorem. Now don't try any negative number, 0, just try the positive one. It is natural to think about 1. Okay, so what you will do at the beginning, again, I advise you to use the synthetic division, even with 1 at the negative one, because you will save your time if you are lucky and they are zeros. So you should write this in descending order from the greatest to the smallest. So it is 1, -7. If there is any missing one, you should write 0, -12. Is that right? Let's try 1 and see what we get. It will be 1. And we show you that it is 2 and 3. Of course, we know that it will not work. Just you can know at the last step. So here it will be -6. This will be 10. Of course, here if you put 10, the sum will not be 0. It will be -2. So this means that the remainder, if you divide by 1, the remainder will be -2. If you substitute by 1, you will get -2. Okay, so it doesn't work. So what we will do? We will try what? 2. Then it will be 1. Bring 1 down. Here it will be 2, -5, -10. Is that right? And what we will get here? 6, and here 12. So this will be 12 -12 plus 12, 0. Now we are done, but you can try, by the way, -2 again. Sorry, 2 again, because 2 it might be a 0 of multiplicity 2. So it's okay to apply 2 again, to try 2 again. Bring it 1 down. Yes, this will be, of course, you can, now you can factor, because this is of degree 2, you can factor it. So this will be 2, this will be -3, this will be -6, this will be 0. It is a 0 again. So it is a 0 of multiplicity 2, and we have the last factor. Now, our polynomial will be x minus 2 all to the power 2. It is of multiplicity 2. Multiplied by, what is this? It was of degree 3, then of degree 2, then of degree 1. This is x minus 3. And that's it. Of course, you have an option here to stop here. If you stop here, you will get x minus 2 multiplied by x squared minus 5x plus 6. And in this case, this is a trinomial. You can factor x minus 2 times x plus 3, which will give you at the end, of course, x minus 3. No, this is a huge mistake because we said there is no what? No negatives here. So here it is. You can now sketch the graph. If he asks you about the graph, you can know what are the x-intercepts, what is the, where it is above the x-axis, below the x-axis, and so on. Any question about that? Now you should be able, if you didn't solve this exercise, you should be able to solve this, please. The sum of all real zeros of this polynomial. So he is asking about the sum of the real zeros. Try to solve it. During that, I'll take the attendance and pause the record. Any news? Solid? Yes. Who obtained the first zero? Negative?
Negative half, negative 1.
Negative half and negative 1. What is good? How can the Descartes rule help you here?
You know the number of positive zeros.
So how many positive?
One, just one.
Only one positive. So if you find that positive one, that's it. But it might be real. It might be not real. It might be. I mean rational. It might be rational. It might be irrational. Of course, it is real.
Have a negative, negative half and negative 1.
So it works. Negative half and negative 1 works. Good. Good. So first of all, how many possible rational zeros? The possible rational zeros are 4. Look at the leading coefficient, positive or negative 1, divided by positive or negative 1, positive or negative 2. So what is it? Positive or negative 1, positive or negative? These are the possible. Okay. Of course, you have at most one positive real zero. So it is natural to think about 1, but it is clear if you put x equals to 1, it will not be 0 for sure. All of these terms are positive, so it will not be. So it is natural to try negative 1. So let's try negative 1. We will have 2, 15, 17, 3, negative 1. Is that right? Make sure that there is no missing term and they are ordered. Now you will have 2. What we have then? Negative 2, 13, negative 13, 4, negative 4, negative 1, 1, 0. So it is 0. The another one, it is negative a half, as you told me. It is natural to start try a half at the beginning. If it doesn't work, go to negative a half. So let's bring this down. So you will have what? 2. It will be negative 1, 12, negative 6, negative 2, 1, 0. So now we can write the factored form of this polynomial. So this polynomial, it is what? X minus 1, which will be x plus 1, times x minus a half, it will be x plus a half, times what? What is the remaining? 2x squared plus 12x minus 2. So this will be 2x squared plus 12x minus 2. We can simplify here, by the way. This will be x plus 1 times 2x plus 1 over 2, and you will cancel it with the 2 that you will factor out here from as a common factor. So you will have here x squared plus 6x minus 1, and this will be cancelled. Is that right? You can write it this way or this way, they are equivalent. They are the same. Now, what was the question? The sum of all real zeros. So what do you think? What we can do more to continue? Can you factor this, or it is a prime polynomial? You cannot factor it. You cannot find two numbers, two integers. The product of them is 1 and the sum of them is, of course, 6. So what you will do in this case, you may use the quadratic formula negative b plus or minus the square root of the discriminant over 2a. This is one way.
The sum of the solution.
Uh-huh.
Negative b over a.
But what about ya Abdulaziz if they are not real? He asks about the sum of the real zeros. This is a very nice trick, by the way, if they are not real. You will do a mistake in that case.
You find the discriminant.
Aha, this is a good idea. So now if you try to solve this one, what will be the discriminant? The discriminant will be b squared, which is 36, minus 4ac, which will be plus 4, which is what? 40. This is not a perfect square. So we will know that the solutions are what? Irrational, but real. So they are irrational real numbers. So now we can use the idea of the sum. So the sum of the solutions will be what? The first solution is -1 plus the second solution is -½ plus what will be the sum of the solutions? What they are, whatever they are, the sum of them will be what? -6. Calculate this, you will get -2, -3, -12, -15 over 2. And the answer is what? The answer is C. But again, be careful, guys, because there might be, of course, complex numbers here. So the sum of them will be just -1 minus ½ Yes. Do you remember from section 1.4 how to find the sum? If you have a x squared plus b x plus c, what will be the sum of the solutions? Will be -b over a. You remember that? We use it here. -6 over 1. So it is not necessary, by the way. You can find them by using the quadratic formula if you want. Okay, but of course, and here we are sure because the solutions are equivalent. The solutions of this expression are the solutions of the original one. So they are equivalent equations. Okay, now you should solve this one, please, please. The total number of the x-intercepts. So when they ask about the x-intercepts, they are asking about what? No, they are not asking about the zeros. The real zeros, yes. Because you know that the x-intercepts are real zeros. Because the complex, the non-real zeros are not x-intercepts. Abdulaziz, what are the possible rational zeros here? Abdulaziz, I'm asking Abdulaziz Sarafi. No, this is not about solving. What will be the possible rational zeros for such? From 1? 1, 2, 3, 4, 5? No, this is not an answer. Positive or -1? Positive or -2? Positive or -5? No, no. You didn't get the idea, Abdulaziz. No, it is not about that. This is about the rational zero theorem. The rational zeros theorem says the factors of 8 over the factors of 1. It is easy. The factors of 1 are there, so don't think. Just think about the factors of 8. What are the factors of 8, Ya Sayrafi? What are the factors of 8? The numbers that can 8 be divided by? 1, 2, 3. 8 can be divided by 3. 4, and then 8. Excellent. So, Hassan, yeah, Hassan, is that right? Now, the possible rational zeros, are positive for -1, positive for -2, positive for -4, positive for -8. Is that right? No. Why? Why there is no positive zeros? MashaAllah alayk, Ahsan. Did you notice that, ya Shabab, or not?
Yes.
You should notice it from the beginning. What is the benefit of the Descartes rule? This is, in fact, one good example about how to get benefit from the Descartes rule of science. Notice that there is no change of what? No change of signs. Okay. So no variation here. The number of variation is 0. So we can conclude from the beginning here that no what? No positive real zeros. For the graph, what does that mean? There is no positive real zeros. So if you look at the graph, what will happen to the graph when we say no positive real zeros? There is no x-intercept when x is greater than or equal 0. So on the right of 0, on the positive part of the x-axis, there is no x-intercept.
So just the second and the third quadrant.
It might be. No, it might be. No, it might be in the first, but the x-intercept will not be. It will be in the first quadrant, go to the second, then go down. No, it means that there is no x-intercepts in the positive part of the x-axis.
It just will be down to the, there's no up to the right.
No, why not? No, it is no positive real zeros. It means no x-intercept when x is greater than or equal 0. This means no x-intercepts when x greater than or equal 0. Yes.
Can a 0 be repeated 3 times? Because -2 it comes repeated 3 times again.
Again, could you repeat what your question?
Could be a 0 repeated 3 times? Because
Why not? Why not?
-2 comes
5. What is the degree here? 5? It could be 5 times. Why not?
Okay.
It could be 5 times. So here we said no positive real zeros. So this means that we will try only what? The negative ones. So here the possible rational zeros are only the negative zeros. It is natural to start with -1. Try -1. It works or not?
No.
So -1 is not a 0. So go to -2. So it will be -2, 4, -6, -8, not 6. Then we have here 5, -10, 4, -8, 4, then -8 again, and we have the remainder is 0. So it is a 0. So we will go to -4. No, if it is a 0, it could be a 0 of multiplicity. So try it again. Divide by -2 again. So now what you will get if you divide by -2 again? You will get 1, -2, 2, -4, 1, -2, 2, -4, 0. Enough for -2?
No.
Why not? It might be of multiplicity 3. So apply it again. Divide again. What you will get? 1, 2, or -2. -2, 0, 0, 1, -2, and it is a 0 again. Could we try it again?
No.
Why not?
Because it's the only possible answer is 1.
If you want, you can try it again, but it will not work, of course. Now, our polynomial will be x minus -2, which is x plus 2, all to the power 3, multiplied by, this is a polynomial of degree what?
X to the power 2.
Degree 5, degree 4, degree 3, degree 2. So this is x squared plus 0x plus 1. Of course, this is, of course, if you divide by -2, it is not a factor. This is a prime polynomial. So the question was about the total number of the x-intercepts. So what is the total number of the x-intercepts? 3 or what?
1.
Or 1? Khalid is saying 3.
No, it's -2.
Does the graph will intersect the x-axis 3 times? only one time. It will cross the x-axis one time. You are saying two times. One time, be careful. So now, what about this factor, Shabab? This is in fact, if you want to factor this completely, as we will do in section 3.5, this will be x plus I times x minus I, if you want to write it as a product of linear factors. But of course, the zeros, the complex, the non-real zeros are not x-intercepts. You can remember just the graph of y equal x squared. Do you remember this graph? Y equal x squared plus 1. This is the graph. There is no x-intercepts. So the complex numbers are not x-intercepts. The x-intercepts are the real zeros. Okay. So how many, the total number? So we have one x-intercept at x equals what? -2. So if you sketch the graph of this polynomial, how it looks like, Shabab? Look, this is the x-axis. If you sketch the graph, the x-intercept is here at negative, and it is of degree what? 5. The leading coefficient is positive, so it will be up to the right, down to the left, something like this. And of course, it will, because it's of degree 5, it may stay touching for a while, then go up like this. So why, Abdulaziz, it will not go up? It can go up. Just it cannot cross the x-axis in the positive direction, in the positive part of the x-axis. Now let's go to the last recitation exercise. Please let me just write this, because I think I will upload the solution in the Blackboard for this. I will save this and upload it in the Blackboard. Now sketch the graph of this polynomial. This is a good review for chapter for 3.4, 3.3 and 3.2. 3 sections in one question. I will pause the recording. How many possible rational zeros? The possible rational zeros will be the factors of 1, the factors of 3 over the factors of what?
2.
Of 2. So they will be what? Positive or -1, positive or -3, positive or -1/2, positive or -1/3. So these are the possible rational zeros. Which one you tried at the beginning? Of course, 1 and -1. Any one of them? 3 over 2. Why third? I said third. It is third. This over 2, 1 over 2, and 3 over 2, right? So here it is. Natural to think about 1 and -1 at the beginning. Does any one of these two works?
No.
No one and -1, they are not working? One is clearly working. Just look at it mentally. You have there 4 plus 3, 7, 7 minus 7, 0. So 1, it works. And you need only one rational zero. You can factor it, it's of degree 3. So what you will do, you will write this 2, -7, 2, 3. Be careful about ordering them in the right way and writing the missing. So divide by 1, you will get 2. This will be 2, -5. Then -5, you will have -3, -3, 0. And you can now think about the other zeros, but no need. Because now our polynomial will be what? X minus 1 times 2x squared minus 5x minus 3. And this is trinomial, a polynomial of degree 2. You can factor it easily. This is x minus 1 times 2x times x. And this is 3 minus, and this is plus 1. Check. 2x squared, -6 plus 1, it is -5, -3, right? So now, what are the zeros now of our polynomial? The zeros are what? -1/2, 1, and 3. And of course, all of them are of multiplicity 1. So the graph will cross the x-axis at them. Now, what else we need to know? What is the degree? The degree is 3, odd. So what? You need to ask yourself, first of all, about the leading coefficient. What is the leading coefficient? 2, so greater than 0, positive. You can say that it is positive. What else you need to know? The degree, the leading coefficient. Now the end behavior. What will be the end behavior? It will be up to the right, to the left, down to the right. What is that?
Up to the right,
Down to the left, up to the right. Okay, so we can now go to the graph and start sketching the graph. This is x, this is y, this is the origin. This is -1/2, let's say. This is 1, and this is 3.
all of them will cross.
1 is here. So here it will be, at this point, it will be up to the right, down to what? To the left. All of them are crossing, of course. It will do something like here, like here. You can know the y-intercept. What is the y-intercept? The y-intercept is 3. So here it is. It might be there or not. I don't know. So we are not interested in the turning points. These points are called turning points. They could be, of course, anywhere between the zeros. Let me show you the graph. The graph is here. Unfortunately, why it is not? I need to work on that again. Anyway, it is similar, almost the same as we did. Yes. Now, yes.
-5.
What is that?
What
At 2, when x is 2. The lowest point here. We are not interested in the turning points. We are just about the x-intercept. The x-intercept, the y-intercept is 3, as we mentioned. It is up to the left, down to the right. Again, it is down to the left, up to the right. Any question about this? Look, let's have a look at the old exams, yeah, shabab. I think now about some old exam questions. According to the Descartes rules of science, this polynomial has a total of either 2 or 4 or 6 real zeros, 4 or 6 real zeros, 2 or 4 real zeros, 1 or 5, 1 or 3 or 5. How to know?
By variation.
By the Descartes rule of science. Do it, try it.
واحدة بس.
Is it A or B or C or D or E? Sure? Why? For the positive, it is easy. For the positive, how many times the sign has been changed? So there is only one positive. For the negative, what you need to do to know about the negative? You need to replace x by negative x. This will stay the same. This will be negative. This will be negative. This will be positive. This will be -1. Now, what is the number of changing? How many? The number of variations? 1, 2, 3. So this means that the negative real zeros are what? 3 or 1. So now let's calculate now the possibilities. So we have positive only 1, negative. We may have what? 3 or 1. So when you have 1 positive and 3 negative, this means that how many real you have? You'll have 4. Or you have 1 and 1, so this means that you will have what? 2. Now, what about the other? Because you know this is a polynomial of degree 6, according to the fundamental theorem of calculus that we will study in the next class, inshallah. There should be at most, of course, 6. So if we have 4 real, this means that there are still 2 non-real. And here, if you have 2 real, still 4 real. But the question here is about what? It is not about how many positive, how many negative. It is about how many how many possible real. So this polynomial has 2 or 4 real zeros, and the answer is C. All right.
كيف تأكد إنها ريل أو ريل طيب بدون ما
بدون ايش؟
ديكارت يعطيك تكوين بس.
Descartes rule of sign, it is about the positive and the negative real signs, of course. Again, I told you this when we studied complex numbers. The complex numbers are not ordered. You cannot compare between them. You cannot say that this is positive complex number, this is negative. The positivity and the negativity, it is a real property. It is for real numbers. Okay, let's have a look at another old exam question. And you can notice that they are very similar to the recitation exercise. The number of all the x-intercepts. So what you will look after? The real zeros. And if they are not repeated, of course, they will be equals to the number of the x-intercepts. If you have a real zero that is repeated, it is one x-intercept. Okay? And this is so easy, Shabab, because what are the possible rational zeros here?
One negative one.
Only positive or negative 1. So you will try 1 or negative 1. Okay. The polynomial has 2 rational and 2 irrational. 2 rational, 2 non-real, 4 rational, no real zeros. How to solve this one? You can use Descartes to minimize. It will help you, by the way, here Descartes in the negative, not for the positive. If you replace x by negative x, you can notice that the sign will be changed how many times? 1, 2, 3, 2 times, 2 or 0. So it is not that helpful here. What you need to do to solve it, you need to find all the possible rational zeros, then try them. Of course, there will be only 4. Positive or negative 1 over positive or negative 1 and positive or negative 2. So they will be positive or negative 1, positive or negative half. These are the possible rational zeros. You will try them and then factor it completely. Of course, you need to apply it for 2. If you have quadratic, you can know about that. Again, we will leave it for you. The polynomial has the same idea, almost the same idea, the same question, but this is easier because it is of degree what? 3. You need to find one rational zero, and then you can find the others by factoring. The number of non-integer rational zeros. What is that? Is it irrational? It means, be careful. It means that is not, the denominator is not 1. Non-integer, it is rational, but not integer, because you know that all the integers are rational. So we are looking in this question for like, if you have like 2 and third. So they are talking about third here, not about 2. Okay. The polynomial has no rational, 6 rational, 2 rational, irrational. By the Descartes rule of signs here, we have what? We have no positive. What about the negative? So what? No real. Is it an option? But he said no rational. It has no rational.
Because all of them are positive numbers.
The answer is it. Just by the Descartes rule of signs. Okay. So what you can know about the zeros of this polynomial, about the x-intercepts, how many x-intercepts? No x-intercepts for this one. Not because it has no rational, because it has no real. Because it has no real also. Okay, I think that's it, Shabab. This is enough for today. Thank you. And